All right, so one of the Hackerbox projects is to build out of a ATX power supply a bench PSU that has 3.3 volts, 5 volts, 12 volts, 12 volt minus, and a variable output according to their little sticker here. Now, you could build it into the front of the case if you wanted to get super creative and pop the case open and get drill in on things. But I'm gonna, well, we're still gonna open the case, but I'm gonna use this one because this PSU, because it has nice nice jacks and external plugs that you can use to cable up to your front panel, and then you could mount this PSU inside of some other container, some other case, in order to produce your bench PSU. Some people will put a couple of these in a case even and gang them up with insulation between the chassis, because what they do is they connect the negative 12 and to the ground of power supply B, and power supply B then has a 24 volt capacity. But we're not going to do that. We're just going to modify this one, take one of these cables and hook it up to the front panel here and get ourselves a maybe just mount a little something up top. Yeah, and that's the plan. So a few things about this gob of wiring right here, which we actually may or may not use. The important wire is the green, well, one of the important wires is the green one, because this is the sense or power supply on wire. And when this gets shorted to ground, so when its level is brought low, it will turn the power supply on. And so this is how the power supply communicates with the front panel switch on a computer. That switch just shorts this to ground, the black wires to ground, and turns the power supply on. So let's just see how that works really quick. Okay, so I've plugged the power supply into the wall. Notice that there's a switch here. This is just switching off the power to the circuitry inside of the power supply, and if I turn it on, it does nothing. But all that's doing is actually switching the power that's coming into the power supply, so it now has a chance to turn on. So in order to turn this guy on, all we have to do is take pin 16 and short that to ground. That's too big. Let me get a jumper. Pin, sorry, did I say 16? This pin anyways. Come on. Stick in there. And then short that to ground, which is, and then turns the power supply on. And when that is not shorted to ground, it turns the power supply off. I don't know if you can see the fan or if you can hear the fan or anything like that, but if you take a look in there, you can hear the fan going. That turns the power supply on and off. So, in the Hackerbox, we had some switches and a pot. This little switch here is what we're going to use to turn our power supply on and off. Have I opened this one? Yeah, I have. I don't know. Let's take a open and find out. Now, we should probably be a bit careful when we're pulling these guys open, because there are dangerous voltages in there. First of all, it's line voltage. Second of all, it's got some capacitors that store charge to filter the power supply out. So you do have to be a little careful when you're digging around in these things. but that's not going to stop us, is it? And you come off of there. You come off of there. Okay, so the things to watch out for are these big capacitors. They can pack a punch if you're not careful. The other thing to look out for is underneath here are some other capacitors. So you got to be careful in there too when you're poking around getting this stuff out. But like I said, we're going to modify as little as possible and just do a proof of concept. Anyways, a bit about how this guy is set up. There's going to be a high voltage side and then a low voltage side. And you can see some right in here are opto-isolators, and that keeps the two sides, the high voltage side and the low voltage side of the board, separated. We've got some big heat sinks for cooling off the chips. This power supply wouldn't be a bad one to do modifications on because there's a fair amount of space through here. So we could pull this board out and wire things into it and actually maybe just feed the banana jacks through a cover plate that goes over top of here. But yeah, exercise for the reader. Red and black are indeed +5 and ground. Green is power supply on, as we were seeing. But the blue wire, that is the -12 volt wire. The the orange are 3.3, and then yellow is +12. And these two, the purple and the gray, they're interesting because they provide a standby voltage of 5 volts when the power supply is on. And then the purple provides a standby voltage, and the gray will provide voltage if once the power supply has been turned on, all of the voltages that are present on the other pins are within spec. So there's a sensing in the power supply that determines whether or not you've got +12, -12, +5, and +3.3, and they're all within specification. So you can use that wire, the gray wire, to indicate whether or not your power supply is functioning correctly. And in order to use those, all you would have to do is put a little LED on either of those. Like I said, they're both 5 volts, so just put a 300 ohm resistor in front of an LED, 5 volt LED, and you would get a reasonable indication for both of those. So yeah, that's what all of these wires mean. Then of course you've got another collection of those on your going out to various other devices. Now, you might notice that on some of these yellow wires, you've got some that are yellow and black. There will be more than one 12-volt rail in the power supply, and what that means is there will be more than one 12-volt supply logically inside the power supply. So, or not logically, physically inside the power supply. You can get more than one 12-volt rail, but all of the 5 volts are coming off of the same rail. And all the 3.3s. So yeah, that's what all of those cables mean. And now we're going to start hacking into them to produce our little project. Right, but before we do that, let's just confirm our suspicions around the pinouts. So check that with the ground. So what am I measuring here? I want to be measuring volts. 20 max. Okay, so the orange, the pins are up at the top here. 3.378, 3.378. the blue should be negative 12. Yeah, that's a negative 11.986. The red should be 5, nice 5.06. And then the plus 12 should be over here. And there we go. We got 12.1, 12.2. It's not bad. Now, let's check our 5 volts coming from our purple. That's and our gray. Both of those should be plus 5. But now, remember, if we've got our power supply turned off, we're still going to get, now where's the ground? We're still going to get a voltage on the, what is it, the purple? Yeah. So the purple still gives you 5 volts, even though the power supply is off. So that's how you can tell whether or not your switch on the back is turned on. Or if you want to power something without having that power supply on and you're putting it all into a single cabinet, there is a 5 volt rail that you can pick off, even though you don't have all of your high current cables enabled. Because we should remind ourselves that this power supply is capable of producing half an amp on the 12 volt minimum, but up to 25 amps on the 12 volt rail, 22 amps on the 12 volt 1, 12 volt 2 rail, 28 amps on the 3.3 volt rail, and 26 amps on the 5 volt rail. It can deliver a lot of juice. It is, after all, a 550 watt power supply. So, 150 watts on the 5 volts, 384 watts on the 12 volts, and 534 watts total load. So they call it a 550 power supply, but it's rated for 534. It's a lot of juice. So if you don't have to have those enabled, just in case you drop something across them and short it out, although these things usually have short circuit protection in them, and that's not going to cause any major problems, usually. Don't take my word for it, always check. But yeah, so you oftentimes would like to have a small 5 volt rail without having to turn on all of your high current devices. So if you've got something connected to it, but if you still want to have like something driven from it, you can do that. So yeah, let's take a quick look at these guys and see how those are supposed to be mounted onto a panel. If we take a look at this thing, we see we've got basically something that you can clamp a wire onto with, and inside there is a place for a banana jack to slip in. So something like that, right? Something like that. If you take that off, or just a regular banana jack if you're not using that. You could also wrap a wire around there and clamp it. So this rod is live, so you have to insulate that rod from the chassis, and what they've provided here is, and you slip that over there, so the hole in your panel will be that diameter, and then you slip this over top to basically clamp your binding post using this washer and a nut onto your chassis. So you would be clamping it like that. Now that just seems a little bit insubstantial, this thing here, because you're putting a clamping load on a thin piece of plastic, pressing down on it like that. And you have to be, I think you'll have to be a little ginger in how you tighten these up onto your panel. But nonetheless, that's what's been provided, and that's what we're going to use. So I'll probably get a piece of sheet metal just to clamp it onto, so we can see what what that does and how to do that. And once the weather warms up a bit tomorrow, I'll run out to the garage and do that there. But for now, we're going to hook up some of these wires to our variable voltage output driver and hook up a voltmeter so that we can see what that looks like. So here's our variable output power supply. And in order to make it a little more user-friendly, the idea is to replace this trimmer pot with something that you can mount on a panel. So using something like a regular potentiometer. Now, this is a single turn, or not quite a single turn pot, and this is a multi-turn pot. This is probably a 10-turn potentiometer. So this is a much finer adjustment. You can get panel-mounted trimmer potentiometers as well. eBay is your friend here, and you can probably find these for, you know, $7-8 if you wanted to make something a little more skookum. You don't have to, of course, but you know, a single turn pot will work just as well. It's just less fine. You don't have as much fine control. So if we look at the bottom of the board, you'll notice that there's a trace that goes to these two pins. So really, all you're not using this as a voltage divider. You're just using it as a potentiometer. So you just connect two of the pins of the pot, and it will adjust the voltage. Now, it would be useful to know whether or not turning clockwise increases the voltage or increases the resistance or decreases the resistance, so that it actually makes sense that it goes in the right direction. But if you find that you are decreasing the resistance as you turn clockwise, just flip the wire to the other side, because, well, that's the way pots work. They have a little wiper inside, and so you want the potentiometer to have zero. You want it to be direct short, or sorry, you want it to be a direct short when it's left, and then you want to increase the resistance as it turns up. And our meter is the next part of the puzzle. So the way the meter works is it's got a black's minus, red's positive, and white is detect. So that's what it's going to measure. The LED is going to be powered by the black and the red. So we'll just see how that works. I've got this connected to 5 volts on my vent supply. So red and black turn on the voltmeter, and so now when I apply it to the 5 volt rail, I get a measurement, 5.1 down to 0. 5.1. I take it off down to 0. So this is what's going to be sensing the amount of voltage that we've got. We need to connect our black and our red to a 5 volt supply. So one of the things that I'm thinking of is powering this meter off of, remember we had that that nice little power ready indicator. So when you turn your power supply on, your voltmeter will illuminate, and that will function as an LED for your power supply being energized. Not that the outputs are energized, but that the power supply is energized. So the other thing that we could do at this point is we could check to see how this guy is actually operating by using our voltmeter and another power supply that's going to power those the in ports here, and then we'll measure the power coming out. So there's a ground there, and then we can measure the voltage coming out as we adjust our trim pot. So let's try that. So in order to do that, let's first of all connect up our multimeter to our multimeter to the output side of our power supply, and then I'm going to connect up 12 volts to that side of our adjustable voltage supply. And then I'm going to connect some ground wires together, and then we'll be ready. Okay, so we've got ground connected to ground. That should be a common ground across. So yeah, if we take a look at the back of the board, this is a ground plane here, so we only need one ground connection because both of those are at the same potential. Now, I've got 12 volts coming in on here, and so when we connect it up, we should get, 19.4. I forgot. That's a boost buck converter, it appears to be, because if we can adjust it down by turning it counterclockwise, we should be able to bring it down to, well, below 12, that's for sure. So yeah, it's got a very nice fine adjustability. Down to 6.8, 5.3. Now let's see, how accurate is that little jobby? Let's do some measurements with a real multimeter. Can we see that there? Barely. Okay. And I'm measuring voltage up to 20. All right, let's see what we get out of this thing. 5.25. Not too bad. It's reading 5.3. That multimeter says it's 5.5. Let's do some more adjustments on this thing. Bring it down to 2.8. See what we get here. 2.78. 2.8. Wow, not bad. Down to rounding error. I like it. So the next step is to replace this guy with the this potentiometer and make sure that we've got it hooked up in the right order so that it actually operates in a logical fashion. Okay, let's put a little flux on our desolder braid. Suck up some solder here. Some isopropyl alcohol to clean the flux residue off. And now we need some wire to wire that up. It's probably a good idea to figure out which side of our potentiometer that we need to solder to which connectors. So that's the way it was oriented in the circuit board. So if I take a resistance measurement of those two pins, I try to take a resistance measurement of those two pins. I get 1 ohm on that side and 8.8 ohms. It's a 10 or a kilo ohms. It's a 10K pot, so that plus that is equal to 10K. So this side is the low side. Now if I turn it up some, what do we get? Okay, yeah, turning it clockwise increases this side, and is that the same thing that happens with the pot that we're going to use in our project? This one is a bit easier to manipulate. That's 10, 7, 6. No, it's backwards. So clockwise makes that side small, counterclockwise makes that side big, so we want to solder it in like that. So we want to use those two the left two most pins. Okay, so now we've got our pot soldered into our board. We've got our multimeter hooked up again with our sense wire going to the multimeter, plus and minus 5 going to the multimeter, ground going to one of the ground points on our variable voltage board, and plus 12 going on there. So contact. There we go. Oh yeah, look at that, way up at the top. Turn it down, counterclockwise, turns it down. Yeah, and it goes down to 1.3, and then it goes up, but it's very sensitive. It's very sensitive. So I would actually, if you don't mind waiting for stuff to come from China, or if you want to go down to your local electronics shop, getting yourself a good 10-turn panel mountable pot. I got these things off of eBay. I think there were $7.50 each. If you went down to the electronics store, it would be more than that, obviously. But you can get them with a nice multi-turn knob, which I don't seem to have handy right now. But yeah, totally recommended, because this really is quite touchy. I mean, you just barely touch it, so it's very difficult to get exact voltages. But I mean, you can dial it in, close to what you want, and then tweak it a little bit, and you can get close to 12, and you can probably get close to 5 by just twiddling it a little bit. But it really is much better to have a multi-turn pot on there. So yeah, so that's the basic idea of the power supply. So you figure out a way of mounting this inside of your case, whatever you're going to mount it in. You feed 12 volts in here, you feed 5 volts into here, and then this is connected to your variable output, and it will sense what the voltage is on your variable output. So hook one of these up to ground. So let's try doing that, and we'll show you what that looks like. Okay, so I just quickly alligator clipped in a binding post to the high voltage, to the voltage out on our variable board, and I alligator clipped onto the ground plane another binding post. And so now we can do things like hook a load up to it and see what we get. So, I mean, it's just a multimeter, but what am I measuring? I want to measure voltage. I'm up around 6. So let's pop some test leads in here. .9. So are those going to stay while I adjust things? No, probably not. Oh yeah, okay. There we go. And now, if you can, I'll get my hands out of the way. 11, 15, 18, 19. I'm going to get overload! Because I was on the, there we go. Let's go up to the 200 volt range. There we go. 23, 25, all the way up to 35 volts, roughly. No, it goes all the way up to 40. Nice. So that is how the power supply gets wired up together. The rest of the work is figuring out manufacturing details. Essentially, that is the electronics figured out right there. Now we have to figure out how to put it into a case and make it consumer friendly. And so the consumer is you, so you just have to make it friendly for yourself. Okay, so now that we got the basic electronics sussed out with our existing power supply, let's connect up the power switch and the power to our the power supply that we're going to be using in the project, and make sure that we can get everything working that way. So it'll just be a few different little clippies, and we'll be all in business. Okay, we have to remember a couple of things. First of all, we have to connect our on-off switch to our green, and then we need to connect plus 12 into our variable power supply. Although it could be any voltage rail, to be honest, but there's more 12 volt rails than there are anything else in that power supply, so that will give you the best utilization of the power inside of the PSU. And then the other thing that we need to do is maybe connect a couple of mining posts up to some of the outputs, and yeah, that's all there is to it. Probably a good idea to check that the power supply is unplugged before you start cutting through any of the wires. Just saying. You don't want to do a medi on yourself. Okay, let's pop those two off, and then we're just going to solder those onto that switch. Okay, so we have that soldered on, and now plugged in, turned on, and now we have an on-off switch. There we go. Easy peasy. Next, we're going to hook up some 12 volt to this guy. All right, so now we've got power switch and a 12 volt rail connected to the input side of our board, in plus, in minus. We've still got our pot connected, haven't broken that off, and now we just need to solder in our multimeter, or our voltmeter. Now remember, we're going to use our standby voltage as the power for the meter, so that it provides a dual purpose. It provides an indication that the power supply is on, and then it also does our voltmeter readings. So we'll take the purple wire and a ground wire and connect that up to our multimeter, or our voltmeter. I keep wanting to call it a multimeter. So now we've got enough to do some bit of testing. So right now everything's off. I turn the power switch on to the power supply, and our meter shows 0 because nothing's turned on the power supply. The voltage rail isn't turned on. When I turn on the voltage rail, it comes up to voltage, and now I can adjust my voltage using my potentiometer. There we go. So that part's working off of our regular power supply, or the one that we're going to use. So that's tested. And the rest is just, see, what else is there? Putting binding posts on the end of these things. I was thinking that some of these could be used as sort of is. The jacks on the front, you wouldn't have to use all of these these wires. You could clip, remove some of the pins out of these, and then you could have plug in 12 volt into the PSU. So you could expose some of those, and then the rest of these could be hooked up to binding posts, and it would make a very flexible power supply. You could even get a bunch of these boost buck converters connected to your 12 volt rails and have all kinds of various voltages if you wanted to or needed to play with a multi-rail project where you have to have multiple power supply rails all at different voltages, and you don't want to go through the trouble of designing a power supply before you figure out if your project actually works. You can just use one of those and you can get dozens of let's see, 1, 2, 3, 4, it's 4 different voltage rails just on this one jack. So yeah, lots of expandability. So yeah, that is basically how that all works. The other thing that I maybe could show is, well, yeah, you know what? This functions as a dual purpose, because when it's showing 0, it shows that the power is on, but when it's actually showing a voltage, it shows that the rails are active. So this provides both a indication that the power supply is on and an indication if the rails are active. So we don't even have to put a second LED on that, although it might be nice to put an LED on this just so that we know whether or not the voltage rails are within spec according to the PSU's internal sensing. So might even put a LED on that just for fun. Okay, so attached to the gray wire is a 300 ohm resistor that I've connected to an LED, and now that thing will go on and off with your power switch when the rails activate, but it'll only light if the rails are in good shape. Now, what can cause the rails to fail? Things like short circuits. So if you accidentally short your rail out, accidentally, that is something that will cause it to go out. So if you didn't notice the short, you will see it. But now I noticed that the LED goes, or the LED goes down. Sorry, the voltmeter also goes to 0 when it goes into the failure condition. So this, I think this LED is just superfluous. Actually, no, it's not, because it's going to be sensing whether or not the power supply is, all of the rail voltages are fine. And this one's only going to be sensing the 12 volt rail that you're on. So yeah, no, it is a useful feature to add to your power supply. And that fan is definitely toast in that power supply. And that's why it was thrown out. Like, I got that thing out of the garbage. So you do not have to spend money on PSUs. All kinds of PSUs will just enter your life if you look for them in the right places. So yeah, there we have it. The what can only be described as, well, it can be described in a lot of different ways, but I was trying to come up with a good analogy for what the ATX PSU is. And I think it's sort of like learning how to play Smoke on the Water when you're early on in guitar. Kind of a riff that you do, and it's one of the fun early projects, I think, in setting up a little home electronics lab. At least I found it fun to make a few of them. So that's an example of one of them that I've made. These are the LEDs that I was talking about. That one stays lit if the power on the back is turned on, but if you turn the power on the back off, which is back here somewhere, that will slowly turn off as the capacitors inside there discharge eventually. By the way, that is exactly why you do not unplug boards from a computer without waiting for about 15 seconds before you unplug them, because there's still voltage being applied to the motherboard. until that 15 or so seconds is up. Anyways, turn it on, it tells you that it's connected to power, and then flick that switch and it tells you that it's live. So this switch, this is going to be illuminated in the way that we've got our circuit set up. That will be illuminated, well, this indication will come from the meter for your output. And then we could add another LED to the other indication wire if we wanted to tell whether or not our rails are live. So that's one example of having built a bench PSU. This is something that I've been working on as well. I was planning on putting a variable power supply in there too, and I wanted to get a few things, both a boost buck as well as a current limiting setup, but I haven't got that quite working yet, and I wanted to put a small signal generator in there, but that hasn't been happening. But I definitely do have this second power supply that I don't know why I don't use more often. But there you go. I just used the one over there because it's my old standby. Anyways, so yes, the manufacturing of these things can be done in many different ways, and you just have to spend some time thinking about how you actually want it to all hang together. And once you're done figuring all of those details out, you can start drilling cases and things like that and mounting the binding posts. So yeah, I think that's about it for now, and thanks for watching.